All right. G'day everyone. Thanks for coming along to my talk on application monitoring with System Centre 2012. Hoping everyone is having a pretty good day. Looking forward to TechFest later on. I've got a couple of prizes to give away during the presentation, so I'll ask a couple of tricky questions to keep you on your toes. And someone can take away one of those helicopters that everyone seems to be so interested in. My name's Bevan Sinclair. I'm an infrastructure consultant with Intergen in Wellington, and I'm also a Microsoft VTSP in the private cloud. Just to start off, I'd like to give you a bit of background on some of the stuff we've been working with SCOM. Recently, our team at Intergen were asked to work pretty closely with the Microsoft US and design an application that would allow presenters to show off some of the features in APM and not just APM, but SCOM, VMM, and a few other of the System Centre products. And this led us to developing a series of slide decks and presentations that they've been using around some of the events around the world over the last few months. It also allowed us to get a good insight into how Microsoft viewed the products such as SCOM and peek under the hood of some of them and just feel for its strengths and its weaknesses, where some of the gotchas were and where we could really apply them to our customers and where Microsoft were taking these applications later on. And one of these strengths that we recognised early on was application monitoring. It was first released with SCOM 2007. It was called AviCode, and it was a plugin that you could download and install, and it provided a pretty rich set of tools for debugging and tracing web applications. With SCOM 2012, this has been integrated into the product, and it's been rebranded as Application Performance Monitoring, or APM, and it's been extended to support a wide variety of .NET applications. A lot of new code has been rewritten from the ground up. So they've taken the AviCode product and they rewrote a lot of the code to handle a lot more of the more modern .NET applications that are out there and sanitize a lot of it to make sure it came under the Microsoft standards. And they also include the ability to monitor Java-based applications as well. So you sort of tie this into the list of operating systems that SCOM can monitor, and you can see where it starts to become a real powerhouse for a single pane of glass monitoring solution for your applications. Quick show of hands, who's ever heard a complaint or a service desk call where someone's rang up and said, my application's running slowly? Yeah, it's a pretty common complaint because that's the symptom that most users see. They don't see very specific information. They see an obtuse error message that just sort of says error, or it doesn't mean anything. It's not very intelligible to the end user. So whether it's from a remote desktop session or from an internet browser out on the internet, it's on their desktop, they don't really see big shiny error messages that tell them exactly who to talk to, what the problem was, or who they should talk to. So one of the biggest problems we see for complex applications with multiple support teams and development streams is pinpointing the problem and allocating the work to the exact team. Users often report pretty vague symptoms, and as technical staff, we sort of look at it and go, well, that could be just about anything. So quite often we feel like we need to employ large teams of very specific skill bases just so we can sort of sort out what the problem exactly is. So we tie up a lot of our developers and our SQL DBAs and our engineering guys in triaging problems. So, I know my website's running slowly, but is it the SQL? Is it because I've run out of resources on the front end? Is there some bug in the code? So we sort of need a tool to help nail down those problems exactly. And that's where Application Performance Monitor steps in. Does anybody know what that is? I can give a prize away if someone knows what it is. Hand up. Concorde? Yes. There's the flight deck of the Concorde. When I was a kid, I had that poster up in my room and I thought it was pretty amazing because I couldn't figure out exactly how anyone, especially even 2 people or 3 people, could manage to operate or understand anything that was going on in that cockpit. There were so many lights and dials and whistles and gauges that it was just amazing. And when you installed SCOM originally in the older versions, this is sort of what it was like. You know, a lot of our customers, one of the most common complaints I hear is that when we installed SCOM, we just got so many alerts we didn't know what to do. We got torrents of alerts on just about everything. And this isn't unusual, because by default, the older versions of Operations Manager, they had a broad application of a best practice settings, and they were all enabled. And because they thought when people implement SCOM, we want to tell them how things should be, not necessarily exactly what's going wrong or what they want to monitor. So in effect, this meant that large amounts of alerting and monitoring and all sorts of alerts were triggered constantly, and it gave an overwhelming flood. So in SCOM 2012, this has been more finely tuned. They've reduced that amount of alerts down to a lot of the defaults have been turned off, and while all the features are still there, they're disabled until you enable them. So you can decide what exactly it is you want to monitor. And APM follows in this suit exactly the same. The alerts are set to exact thresholds that you define during the template setup process, which I'll show you in a minute. And it allows us to get a hands-on approach to monitoring our applications from end to end. So who here uses SCOM and synthetic transactions? Yep. For those of you who don't know, synthetic transactions, they're actions that we run in real time against monitored objects. So, for instance, we could use a synthetic transaction to monitor HTTP requests, to check the availability and measure performance of a web page. So it makes a request and then returns the response back as part of the automated agent response. And that will tell us whether the page was up, down, error code, or anything like that. But it can do more granular transactions as well, so it can step through a web page. And against a set of measured or recorded responses, it can tell you whether or not the end user, if there was a person clicking through it, is getting back the information you're expecting them to see. So they're pretty powerful when you sort of combine them with, a lot of the standard SCOM monitoring. You can monitor the websites sort of end to end. Oops. So, as in previous versions of SCOM, synthetic transactions can be configured to ensure that specific end-to-end processes return those expected results. But this doesn't give us the whole story of actually what's going on inside your application. So, sorry. So as users access the application at the front end, SCOM can monitor it and report when the errors are experienced. This is accomplished by APM, and it injects code into the end user web page and measures the time that specific functions take to complete within the web call. So if a transaction takes longer than the thresholds defined by your template, then it'll alert you and say, there's a process that's taking a bit longer than we expected. So if the front end, the mid-tier, or the database server don't respond within your defined times, if SQL calls go off and don't return the information back as quickly as you expect, or there's an error that comes back, it can alert you on that too. So you tie this into the standard agent-based monitoring of all of your end-to-end process, and you can start getting a really good idea of what's exactly going on inside your environment or your application. So it delivers a single tool and a single pane of glass to deliver the defined messages to specific teams as well. So when a manager wants to see an overall service level for a specific service, such as SharePoint, Active Directory, or Exchange, or when the engineer wants to list the alerts or performance for an infrastructure, or the application owner wants to see performance stats, we can all deliver this through a single pane of glass. And it's designed to be easy as well. How many people have written their own management packs out of SCOM, for those of you who use SCOM? Yeah. It's quite hard. It's complex. People look at the effort of creating their own management packs, and while some people, such as myself, get a little bit of enjoyment out of creating them, it's really quite tricky. And so people, when they're implementing SCOM and APM, they don't want to have to spend a lot of time creating a lot of custom management packs, unpacking, repacking, writing XML, editing it, and or even delving into Visio and creating them that way. So we need to be sure that something such as APM is easy to implement. So also we need to be sure that something can be monitored. Developers don't usually have time to add hooks or entry points into their applications for us to plug our monitoring applications into, because the projects don't have enough time allowed for that sort of code writing. So Microsoft decided that APM would do this itself, and it injects itself into the code on the fly and allows us to understand what's actually going on inside the application. And also, because it's installed as part of the Operations Manager 2012 agent, or the agent's actually doing the work of stepping through the synthetic transaction, it means we can still use that single tool to collect and display the information about our application environment. And it's all pretty much out of the box. All the required management packs to enable APM are built into SCOM 2012, or they're easily downloadable from the online catalogue. And configuring it is pretty straightforward as well, and I'll take you through that in a second. So it just depends on the scenario that you particularly want to trace. So a simple home page-based synthetic transaction is pretty easy to set up. You point it at that page and it will return the error code. But you can go into create advanced monitors that do really in-depth, what exactly was going on within that web page when it returned a particular error code and what's actually happening. And for our monitoring solution, it needs to be light as well. You don't want your monitoring solution bogging down your web front end or your SQL database, or having to expand the number of web servers at the front end because your CPU overhead for the agent is far too high. In most scenarios, APM agent only adds about 5% of CPU overhead to the web server, so it's reasonably minimal. It's been tested on some pretty large deployments as well. They use it to monitor Xbox Live and Microsoft.com as well. So you can be pretty confident with those sorts of, the amount of metrics that they get out of that it's not going to be too heavy. So let's take a quick look at .NET monitoring. Previous versions of APM with SCOM 2007 required extra installers, extra databases, and made for a reasonably complex system to manage. So the extra databases had to be backed up. The consoles, you had to have extra parts loaded in to view the APM data, so not everyone had access to all the data that it was collecting. So like I said earlier, all of the framework for APM is installed by default with SCOM 2012. If you look at the agent on an agent-managed server, right next to it is another agent that's disabled by default, and that's the APM agent that sits next to it. And it only gets enabled when you apply a template that attaches to that web server, or it includes that web server. So what happens is your APM agent is the data collector, and it forwards all of the management information and the performance data off to the SCOM server. And it also has a client-side monitoring data collection portion to it as well. So that collects the data that the client has injected in the web page at their end and forwards it back to the operations manager server. So I'll be showing you how to create those templates in a second. At the back end, the APM data is stored in the operations database and the data warehouse. So it's no longer separate databases, so no longer extra management footprint for the back end there. And built into the SCOM web console are the application advisor and the application diagnostics console. This allows developers who are supporting the code to delve pretty deep into the errors and get a detailed information on what they're seeing. And I'll be showing you that in a minute too. So really, to answer the question of how do we set it up, you don't have to do anything. It's already built in. The only thing you have to do is import the management packs. So to start monitoring it, we need to ensure that the correct management packs are installed. For my demo here, I'm using Windows Server 2012 and Windows Server 2008 R2. So I need the 4 management packs that align to the server and the APM for that web server as well. And you can see them listed up there. So once you've imported these particular management packs, you can it'll start discovering which websites are available to be monitored by APM. Now, there's a little gotcha at this point. When it goes out to discover those particular websites, you may find that your websites don't appear in the console under the listed discoveries. What you can do there is if you look at that TechEd article, there are some overrides that you can apply to that particular management pack, and that will allow you to either enforce particular websites to be discovered by the agent, or you can include a rule on a file type included to ensure that they get picked up as well. So once the discovery has occurred and you can see the .NET websites and the web services listed in the SCOM console, they can then be selected for monitoring by using a management pack template. Just another point, in SP1, which is coming out relatively soon, you can actually start monitoring Windows services in the same way that we monitor our websites and our web applications. So any Windows services written in .NET can have application monitoring code injected into them as well. And we can start seeing what they're doing on a performance and error basis as well. So, quickly jump over here. Right. So, just quickly look at the discovered inventory there. So this is a list of the websites that's found within my environment that we can apply the APM templates to. There we've got this separated into IIS 7 and IIS 8 different websites, and WCF web services that we can apply. So I'll go ahead and create a template. It's pretty easy. We just go into the authoring part of the console and go Add Monitoring Wizard. And under there, we select the .NET Application Performance Monitoring. Give it a name. Select the Destination Management Pack. And add the components we want to monitor. As I was talking about, there's the Windows services that you can apply there in SP1 when it comes out. And there's a list of the services that we've got available. Now, you can see that the icons there, can you see that? The icons are slightly different. It's a bit of a gotcha there. It's the only way to differentiate between whether something's a web service or a front-end web application, like a website. I would prefer to see something else there, but that's what you get. So we select the two, one is a front-end and one is a web service there, and select them for monitoring. I can also select an environment here if I want to apply this particular monitoring to a particular environment and a targeted group. So I can create a group of particular servers within my environment. Say of my web farm of 100 servers, I only want to actually apply application monitoring to a small percentage of them. I can create a custom group that targets the deployment of this particular template to those servers. At this point here, we talk about the server-side configuration. So for the Windows services, by default, it turns on both the exception events and performance events. So it'll start collecting any bugs that it detects in the code, plus any performance data that it sees from that web service. The performance threshold there is, by default, 15 seconds. Now, we don't recommend any particular number. That's something that you will have to decide based on fine-tuning and figuring out exactly how long you are willing to let the agent wait before it triggers an alert and says, this is going too slow. So for instance, I think there was a report recently where it talked about the particular end user's experience on a website, and if it was anything more than 6 to 7 seconds, they clicked away. So you could sort of refine your performance threshold down below that 6 to 7 second mark, just to make sure, if you're only concerned about web calls that are going on way beyond really, 6 to 7 seconds could be a reasonably long time, depending on what it is you're trying to do within your website. For this demo, I've set it to 100 milliseconds, so we should get some errors. You can go down as low as 1 millisecond. I'm not sure who's got a website that performs that quickly. From there, we just click Next, and it's ready to go. It will apply, if I click Create there, it will go out and find any servers in my environment with those particular websites or web services hosted on them and apply this management pack, and APM will start doing its work. And that's the express setup, so you can start monitoring straight away. But I'll go back here and I'll enable additional configuration options here and step through. So here I can customize exactly what I want to do for each individual website or web service. I can turn on application failure alerts. I can look for all exceptions. I can even add particular functions or WCF methods that I want to trace specifically for this particular monitor. So if I want to refine it and say, I just want to see the one particular get function, I can put that in there. And then it goes to the client-side monitoring. I can turn on the exception event alerts to show the errors at the front end. Now that's turned off by default. Again, there's the thresholds there, and there's a little gotcha here. It defaults to the local host IP address, so it will only inject the code into the front-end browser if you're browsing from the web server that hosts this website. Now, that is because they don't want, if you go and apply this template, they don't want every single user suddenly getting this code. It's designed to be implemented in a staged approach, and so what you'd do is you'd slowly add probably subnets from different user groups or areas within your network so that you can control who's getting the injected code on the front end and who's not. And then I can select exactly which of my websites that I have in this rule are going to get the injected code. Again, I can target a particular group of servers down the bottom here, and then it's ready to create. And again, once I click Create there, it will go out. The next time the agent on the SCOM agent checks in, it will see that there's been a change to the management pack that you've applied to it, and it will download that information. The APM agent will start up, and it will start reporting information back about our performance and any particular errors. Right. So as you can see, there's a lot of granularity in that configuration. We can really delve deep into exactly how we want to monitor our web applications. And like I said, by default, you can just set it up and let it go, and it will start detecting the problems that you're seeing in or any problems that you're potentially not seeing in your web applications. When you need to tune your APM monitor to get more specific data out of it, the advanced options are there waiting for you as well. So APM configuration for .NET apps can be automated for large environments as well. For our particular deployment, we set it up so the SCOM agent would deploy automatically. The servers defined by the websites that they hosted would be automatically added into all the monitors that we'd created within our management pack, and those management packs would apply. So if you go to a session tomorrow that one of my colleagues is doing on VMM, and it's all about service templates, if he shows you the scale out function, what you can do there is, as each web server is created in your web farm, it is, because we deploy it as part of the deployment process, the SCOM agent, those APM rules are automatically applied, and it starts collecting data on those servers as well. It's quite a neat little feature. Yep. Yeah, they're just same as any other operations manager alert. So if you want to see an email for every single problem that comes through, maybe you just want to see an email when there's a particular code alert, perhaps when one particular function goes wrong, you could set up an email alert to send you an email when that happens. Absolutely. So how do we work with it? So far I've shown you how we configure it and to the level to which we can dictate the monitoring. So what do we do with the alert information when we get it? What sort of information do we get, and how much detail is in there? So it provides pretty rich information about what's happening on your web experience, your applications and your web services. And both support staff and your developers can see exactly where the errors are occurring and what sort of errors they are. We can also plug it into tools such as Visual Studio. So APM alerts can be assigned to particular developers using the Visual Studio Team Foundation Server 2010 management pack. This allows bugs and performance problems to be automatically assigned to the particular team who are responsible for that particular piece of code. And so it means that the developers get an instant update when there's a problem and exactly where in the code that their problem is coming from. And also coming in SP1, it's not up here, but it's the ability to plug it into IntelliTrace as well. So we can go the output straight from APM into IntelliTrace. So for developers, it means that they can bypass all the infrastructure support that's going on and get straight into the information that APM's pumping out and the APM data that's being collected. So when we first look at the APM data, when we've just set up our monitor and it starts telling us about all these things that are going on, we tend to be quite reactive. We tend to look at the information and go, well, here's an alert, let's deal with it. And that's fine, because that's what you do. When you first start collecting error information or performance data, you start looking at exactly what's coming in and figuring out whether or not that's actually a problem or whether it's expected or whatever. So what I'll show you now is we will look at the information that comes in from APM. So those two monitors I have set up, there's the IS7 and IS8 one. I've just labelled them like that. I could theoretically just lump all of the websites and everything into a single rule, but I like to separate them out. And we see these sort of alerts that we're getting through. So you can see here there's some client performance exceptions. There's even an alert telling me that I've had a lot of performance exceptions in the last 24 hours. And I've got some server connectivity exceptions, some errors down there. So what do we see when we see one of these alerts? Well, if we drill into the actual alert that's coming from APM, what it's showing us here is exactly what's happening at the client side. So this particular alert is a client-side performance alert. Like I said, my threshold's set to 100 milliseconds. So it's detected that the page load at the front end has taken longer than 100 milliseconds, and it's returned all the information about what's been happening while that page was loading. So as you can see over here, it's telling you how, in a percentage, and how much information was downloaded to that web client, how long each of the particular phases of that web load took. And you can see that the network request took a whole 74 milliseconds, and then the DOM load on the page, and then the peripheral load also took around about the same amount of time. So it splits it out into all the different functions that are going on in there. So it gives you a lot of real information about what's going on at the client side and how long everything's taking from a performance point of view. For a server, this is a particular services error. And so what we can see here is this particular call, the threshold again was 100 milliseconds, and it shows me, it breaks down exactly what was happening and how long each step took within that web service to execute. So each step took a certain amount of time, and it can tell me what's taking the longest time and where my resources are being worst spent. So if I may particularly think that the SQL calls are taking a long time, and in this particular one, it was the SQL call that took the longest amount of time out of the two. The internal execution time was only 38% of the actual entire event that happened there. And if we're wondering at the time whether or not this could be linked to perhaps performance problems on the web servers themselves, then we can look at the performance stats that are happening as that particular event occurred. So I can look at, it saves up to 15 minutes before that event to show you what was happening on that web server just before that event occurred. So that is an error, and again, that one's a pretty simple one because it throws back the exact error that was happening on the web service at that particular time. And it's again, that's a reasonably simple one. It's just saying that it couldn't see the remote server. Part of the other things, the other features of Application Performance Monitor, we can drill a bit more down into what's going on by looking at the application diagnostics. And this is a web console that I was talking about earlier that shows all of the application diagnostic events that are coming through into the APM database. So here we can see a list of every single event that's going on at any particular time and drill down and see more of that really rich information about what's actually happening during the events and the performance problems that are happening. So on that particular one, you can see that the network request took a whole 100 milliseconds again. But we can also sort, I can group these by problem as well, and it can start giving me a bit of an idea as to exactly what my major problems are. So if I sort them by the number of errors that have happened, I can see that application failures on the home index page seem to be happening reasonably frequently. And this can start giving us an idea of what we want our developers to work on next. So instead of chasing every single event that comes through, we can sit there and say, well, the most frequent error that our clients are seeing are these home index page fails. And we can also drill into the errors again from there and also show similar events and related events as well that are going on at the same time. We could also search for performance issues and group them by the heaviest resource. So perhaps we are looking for what exactly is causing most of our performance problems on our front-end web server. So the count for that particular one, it's the network request from that particular that particular address. But the one that takes the longest, if we sort it by duration, is actually this WCF call. Again, we can drill down, we can look at performance counters and see what was going on at that particular time, and we can look at similar events of the same type and figure out whether or not it's actually is it an intermittent thing that happens? Does it happen at a particular time of day? Does it coincide with our backups? You know, all sorts of things, but it can give you lots of really rich information on exactly what's happening there. Right, so that was reactive. You know, you're taking the information that's coming in. Oh, sorry. You're taking the information that's coming in and just reacting to that as it appears on your screen. Or we can be a bit proactive. And this allows, you know, while the application diagnostics are good, we can leave APM to collect data over a period of time and come back and start dissecting that information and figuring out exactly what's going on over a longer period of time. And so we can start directing our developers to investigate particular problems. The app's diagnostics, so that screen I was just showing you, that's focused on the operations database. So that data is current and it gets deleted after a certain amount of time to keep that database within sort of refined limits. But the data is also flushed off to the data warehouse. And if you actually look at the database sizing spreadsheet for Operations Manager, which you can download from Microsoft, when you're designing a SCOM implementation, if you enable APM on a certain amount of web servers, you'll notice that the database size for the data warehouse jumps. And that's because all of the data that you're collecting through APM gets flushed out to that data warehouse. So it means that over a longer period of time, you can start collecting that data and reporting on it. So that was the Application Diagnostics web console. And what we have here is the Application Advisor. Now, the Application Advisor is a web console that basically takes a lot of the reports that are APM specific in the SCOM console and switches over to the right monitor and says, okay, well, people who want to look at this particular part of SCOM don't want to see all the reports, but we also want to have a few more things in there that are very APM specific. And so it also allows, because both of these are published as web consoles, it means your developers don't have to have the full-blown SCOM console installed on every single workstation. And also, I don't know if you've ever done any sort of traffic analysis, the SCOM console is quite hungry on network activity between your client and the SCOM server as well. So if you have a whole lot of SCOM consoles out there, then you can start to really bog down your management server with a lot of management traffic. So that the web console allows your developers to get access to the information without having some sort of heavy tool installed on their workstation. So if we look at the problem distribution analysis report, and give this a second to warm up. Right. And we pick, I've only had this lab set up for the last 5 days, so there's not much point in me going back too far. But we can select that report to show us all of the data that has been collected over the last 5 days. But we would typically run this over several months to show exactly what's going on. So what we can see here are a ratio of the reports, a ratio of the events that are going on in our application. So you can see here that a majority of our events that are occurring are performance events. And there are a few scattered application failures, and there's even some connectivity problems as well. And that gives us a little overall graph. But it also tells us which one of our websites or web services is having the most problems. As we can see here, the web services is having a majority of the performance issues, and the web front ends are not. Whereas, well, it's only 3, the front end here is having a lot of failures in the actual code. And so it can start giving us an idea of exactly where our developers should be looking to improve the performance or improve the error, reduce the errors that are happening within our websites or web services. If we scroll down, we can get some overall statistics on the types of resources within our web services. that are causing these particular problems. And we can see here straight away that PCDA services repository is causing 95.9% of our performance problems. So straight away we can say, well, over that period of time, all of those problems came from, or a majority of those problems came from that particular function. And same for the front end, and same for the third one, the other frontier. So we can also then look at the summary failure analysis for the same date range. And this gives us a distribution of all our failures that are happening on our web servers and websites and web services. And again, it tells you exactly where the number of errors that are happening, how many are related to actual failures within the code, what are connectivity problems, and how many are security issues. So if we saw a whole lot of security issues in there, we might deduce that at certain times during the month, someone's resetting a password and then going to do it on the web server. And in that instance, it's getting an access denied on a database, or there's something else going on there. Or the connectivity fault, again, it could be something as simple as every month something occurs where someone disconnects that particular website, or the connection is interrupted, and we can start triaging it that way. Again, you can drill further down here into the actual source statistics. You can also click onto the events themselves, and it will take you to the application diagnostics and start showing you the exact problems again. And again, the performance counters and all that other rich information that you collect on every single event. I've also got the summary user analysis here as well. And this can tell us a lot of really useful information if there are particular users that are having the most performance or errors in their code. Again, it's my particular lab, it was only one user, and that was me, and I was causing all of the problems. So I can deduce that I need to stop browsing that website. But what we can say there is, if there are a particular group of users that are perhaps using the same browser, or perhaps they're all using a certain operating system, or perhaps they're missing a couple of patches as compared to some of the other people that are using the same websites and not receiving these performance or code-related errors, that we can start really thinking about what exactly makes these people different. So we can triage it that way as well. And we can also look at the application failure analysis. Oops. And look into one of the particular websites that we monitor, or web services, and start breaking it down by the application functionality. So we can see here that these particular functions are causing the most connectivity faults, and these particular these particular resources are causing the most performance errors. So those two consoles, the two web consoles, are really useful in triaging those problems and creating a more proactive approach to exactly figuring out what's going on in our environment. So that's .NET. APM also brings a pretty comprehensive support for monitoring Java, Enterprise Edition, formerly known as J2E, application servers. It supports 4 servers. It's the Tomcat, JBoss, the Red Hat JBoss 4.2, 5.1 and 6, IBM WebSphere 6.1 and 7, Oracle WebLogic, 10G release 3 and 11G release 1, and the open source Apache Tomcat 5.5, 6 and 7. Also on both Windows and Linux. And it supports WebSphere on AIX and WebLogic on Solaris. So as a pretty quick overview, it's done in a similar way to .NET. So after importing the Java management packs to monitor, to match your environment, it automatically discovers the application servers. Standard monitoring lets you know that if the application server is running and the resource utilization is within the defined thresholds. For deeper monitoring, Microsoft has an open source Java management extension called BeanSpy. It was previously known as the JMX extender. And it can report to SCOM on a lot of via HTTP or HTTPS and it communicates with the MB encounters within the Java application to monitor the individual applications running, as well as the health and performance of the application server. So what does APM really give you? Well, it gives you a 360-degree view of your application health. We can look at the availability of our web applications. We can use the power of synthetic transactions to monitor web applications from an internal source or multiple sources from different sites within your organisation. So we can set up a synthetic transaction to run from a particular server, so our operations manager server, or one of the other servers that has an agent installed on it. Sorry. And also announced just recently is the new add-on for SCOM 2012 SP1, which is called the Global Service Monitor. And this plugs into SCOM 2012 and can monitor your applications from an external source. There's about 14 locations around the world, like Sydney, London, Sao Paulo, and Northern America. There's a whole bunch of sites. I think there's about 14. And what it does is it runs those synthetic transactions that you create from those remote locations. So you can sit there with your external-facing websites and monitor them from each of those geolocations to tell you what the clients are seeing around the world. Now, for a lot of people who may have a lot of international customers, that's pretty amazing stuff, because you can gather the experience statistics and the performance data from a lot of different places around the world. So we can also monitor the reliability of applications. We can use APM to monitor the client side, the client browser, web services that make up your applications, as we've discussed. And we ensure that the response from the website is being returned within the thresholds that we've defined. And we can also present that information, just like all the other SCOM bits and pieces that we can do within the console. So we can present it as a pure dashboard showing the alerts that are coming through, or we could show it as an SLA to the management, perhaps having it on a big screen, and just having that web service. Does it have a 95% rate for errors, or a 99% rate for avoiding errors? Performance data can be gathered from APM and GSM to generate reports on how our applications are responding. Do we need more SQL? Do we need more web servers at the front end? Are there code or infrastructure issues that may prevent our clients from seeing the application? So, diagnostics applications such as the SCOM management packs with large amounts of knowledge data, custom and built-in, can allow us to triage applications a lot quicker and also respond to the problems. And APM, with its inbuilt knowledge of .NET, also allows us to get straight to the root of the problems. And also resolution. Because we tie into TFS and Visual Studio tools, this allows the developers access to the information on the bugs that require their attention. And the inbuilt reporting tools allow them access to those bug reports from just about anywhere. So, that's about it from me. I've got a question. How many extra databases, just put your hand up, are required to set up APM in SCOM 2012? None. Sweet as. I'll give you one of these afterwards. Sorry. So yeah, if you want to catch another session on other System Center products, I highly recommend that you go to WSV 303, which is on tomorrow morning, if you're available tomorrow morning. It's not that early. It's not real early. It's 10 o'clock, 10:30, I think. So that's building and deploying applications. So it's the Expense Manager app that we built for Microsoft into a service template, and how you can deploy that using VMM. The exam, I don't know if you're in the session before when they talked about the exams, 70246, monitoring and operating the private cloud, is the one that covers SCOM. And if you want to get in contact with me, Bevan Sinclair at live.com, and I'm on Twitter as well. Thank you very much.